Hello and welcome to the Python tutorial series. My name is Daneyallari and today I'll discuss about a very important topic, that is decorators. So before learning the decorators and going to see that how to create a decorators, first few things are required. You should know very well. First thing is first class object, means higher order function. Nested function, how to create and how to return the functions from a function. So if you don't know what is the first class object, nested function and returning function, go and watch my previous videos. I have already uploaded and explain the things very clearly. I will do one thing. I will do a quick recap about these concepts so that we will understand decorators in a very easy way. So first of all, what is first class object? So first class object means higher order function is a function that can be stored in a variable. Since we know that everything is object in Python, so we can store that function. Function is also an object, so we can store the function in a variable. We can pass a function to a function and we can return a function from a function. So let's see, for example, if you create any function, for example, that is my fun here, and if you perform some operation by using this here, and here is my function is one syntax that is written inside this function. So what you can do here is that everything is object, so my fun is also an object. So if you call this function, then it will execute, yes, because we are calling this function. But we can do one more thing. What we can do, we can store this function into any variable also. So let's see, I'm storing this function object into D. So how to do without calling this function? So now D is pointing to my fun, and if I write only D and call this D by using the parenthesis, so eventually it will call your my fun. Just look at here. Okay, so we can do this. Why? Because everything is object in Python. Function is also an object, and function is a first class object. One more thing we can do here is we can return a function from a function. So suppose if you create any function inside your function, that is inner function, and this function performs some operation, print, and here it writes I am inner function. So this my fun can return this inner function. So how to do this? Just look at here by using the return statement, and here you can write inner function. So when you will call this function, that is my fun, it will return inner function. So let's call this. I'm calling. Okay, I'm not assigning. So I'm calling the my fun, and it will pass the inner. It will return the inner function that will be stored into D. It means now D is equal to your inner function. So if I call this D, then we are calling actually this inner function. So let's see. Okay, so an inner function, it is executing. And one more thing you can do here is you can pass any function to a function. So how to do this? For example, if you have any function, for example, display, and it displays something. So here I display the results. So what you can do, you can pass this function to this function. So for that, you will create one variable. So I'm writing original function name. Okay, now this original function can accept this function. So how to pass this? Here, copy, and we pass. So now this function is available into my fun, and I can use this function here, and in fact anywhere. So I will call original function here, and I will call this. So whenever I call this original function, actually it will call your display function. Why? Because we are passing display to my fun. I know this whole thing is going to be messy, but understand this and just wait. Gradually you will understand it. It's in a better way. And these things I have already covered in the previous tutorial. And after calling this function, it will return the inner function that will be pointed by D. And if I call this D, so this will call your inner function. An inner function will execute. First of all, it will call I am inner function, and it will execute the original function. As we know that original function is pointing to display, so it will call your display function. Just look at here. So I am inner function, and I display the results. Okay. So One more thing we can do by using the first class object is we can create the closures. In the previous tutorial, I have already explained that the closure takes an advantage of the first class function and return an inner function that, remember, it has access to the local variable in the scope in which it has been created, even after your outer function is finished. So what is mean by this? For example, if you have any local variable, here is, for example, message. I will take the same variable here. Message is equal hello. This is the local variable of my fun. Okay. Now I'm using this message inside the inner function. And if I call this my fun, so it will call and it will execute and it will finish from your stack. Even after the execution has been finished of this outer function, your inner function will remember this message variable. Just look at here. So as you can see here that I am inner function and it prints hello. Okay, so this is the use of the closure. Uh, Closure is very much useful. So I will now go to explain the decorators. So I hope the concepts are now revised. So what is decorator? By the definition we will implement, and I will try to keep it simple to make it clear, because decorator is very important topic and it's a very advanced topic of the Python. A decorator is a function that takes another function. Okay, that takes another function means we will pass the function as argument and extends the behavior of the letter function without explicitly modifying it. So what is mean by this? For example, this is your one. I'm writing the decorate and here writing func. So this function will accept one function and it will add some functionality to this function without modifying the actual definition of this function that you are passing. So actual definition of this function is display. So I don't want to make changes into the display function definition, but I want to add some more functionality. For that we use the decorator, simple definition. Okay, so how to do this? So here I will write a very simple decorator I will create. I'm creating one decorate. Let me write here is decorate func, and the function that will be inside is called, generally we call it a wrapper. Okay, that wrap your passing function with some extra uh, feature. So generally we call it as a wrapper, and here I will return the wrapper. You can write any function name, but when you will go and read any article, any book, any blog, then you will find that this function will always, you will find 99% that wrapper function. Okay, and here what I'm going to do is I am decorating, or I am adding some functionality. Okay, and now original function. So now this function will add this functionality to your original function, and after that you are calling this. So if you call this d and if you write decorate function here, okay, so this decorate function will return the wrapper. So now d will point to this wrapper function, and when we call this d, actually it will call your wrapper, and wrapper will print first of all this, and then it will call your original function. Okay, let's see. So actually this is called a decorator. Very simple. Okay, so this syntax, I hope this syntax is clear, that how to create a decorator. We call it is a decorator. So let one more time. Decorator means a function that takes another function as argument, add some new functionality to this function without modifying the definition of the original function. That is called decorator. Since we are using the Python, so Python uses one syntax to decorate a function. What is that? Just above your function you will write at the rate and your decorator function name. So my decorator function is name is decorate func, so I can write decorate func. Okay, so this syntax is similar to this syntax. Okay, this syntax. And if I write the display here, so now you can understand this. This only one line is similar to the whole line, and if you want to call, then you can call display here. So if you don't want to use this syntax, then you can use this decorator syntax that uses the Python in a very much in a fashion way. So let's delete this one, and if I call the display function, just look at here. So on the display function, I have mentioned one decorator, that is decorate func. So first of all, it will call your decorate function, it will return your wrapper, and it will call the wrapper, and your function will execute. This is the process of the execution. Just look at here. So I'm adding some functionality, and here display the results. So I hope this syntax is also clear. So you can use either one, this syntax, or you can use this syntax as well. It depends upon the situation, it depends upon your functionality, how you want to use this one. One thing you have to understand here, whenever you write this syntax in and just above your function name, this function will always decorated. This function will always decorated. So whenever you call this display, just look at here, I'm just comment out this statement. Whenever you call this display as many as number of times, it doesn't matter. So it will always decorate with extra functionality. Just look at here. I am adding some functionality, I'm adding some functionality, I'm adding some functionality. So if it is your requirement that if I call any function and it should have some extra functionality that is added by your decorator, so you can write this syntax. And if you want that, when I want that it should be decorated, then it should decorate. And if I call display function, so it should print only the simple syntax, then it's my recommendation, don't use this syntax, use this syntax. So if I call this display, just look at here, it will call your display function plain. Okay, so just look at here, if I call this display, then it prints only display. And if you want to decorate it, then you can use this syntax. And if I call this D, then you can see here that let me comment out this. Now your display is decorated. Okay, so it depends upon your requirement that you want that your function should always be decorated, or you want that it should be decorated when I want in my application. Then you can use any one of the syntax. Okay, so now since I'm talking about the decorator, so I will use this syntax. Okay, one more thing. For example, this decorator adding some functionality to your display. Similarly, we can have any number of function. For example, if I have another function that is called show, and it takes some argument name and age here, and it prints something like, okay, so it prints name first and age here. So I can write name, let me write what, yes, name is and age is. So we can do this by using the format function. I will use here name and age. If I call this show function, and if I pass something, let me write show, and here I write one is application name, that is Java Provis, and age is 3 years, and call this function. So you can see his name is Java Provis and age is 3. I want to add some functionality into this function, but I want to decorate this. So can we use this decorator, because we have already created one decorator that is adding some functionality. So for that I can write @decorate func. So what will happen when we write this one? This function now will pass into this decorate function, and when this wrapper will execute, so it will call your show function. But here, when I will try to this, then you will get error. Why? Because it says that wrapper takes 0 positional arguments, but 2 were given. Why? Just look at here. This wrapper function, as you can see here, is calling the original function. As you can see, this original function will represent either your display or your show. So if you call the display function, then original function will point to display function. If you call the show function, then it will point to your show function. But just look at here the syntax. Show function takes 2 arguments and display takes no argument. So when you pass display to this original function, and this original function calls your display, it matches the number of arguments very fine. Okay, it matches the number of arguments. So the number of arguments is here 0 and here is 0. So it calls the display function. But if in case of show, it has 2 arguments, and when the original function will execute, it has no argument, so it will not match the number of arguments. That's why we are getting error. So if there is a situation, remember this one, and listen very carefully. If there is a situation where you want that a decorator that you have already created should apply on any function that has any number of the argument, then your function, that wrapper, will look like @args, any number of the arguments, and here you will pass @args, any number of the arguments. So this argument can take 0 or more. So if I pass display, it has 0, so it will call the function. If I pass show, then it can pass name and age because it can take 2 arguments. Just look at here. So we are getting same output. I am adding some functionality. Name is Java Province and age is 3. So now by using this syntax, we can use a decorator on a multiple function. And the standard syntax says we should write this one. Okay, so kw argument and your variable number of arguments. So whatever the argument you are using, you are passing, it will accept and it will execute 0 or more, it doesn't matter. Okay, so this is the standard way we should write our decorator. One more thing is here is suppose you have two decorators, and if you want to apply those two decorators on a single function. Here I was creating one decorator that I was applying on two functions. Now the situation will be flipped. Means we have two decorators and we want to apply on a single function. So let's do this. I'll copy and paste because I have already created this one. It will save our time. And let me copy and paste here. Now, one decorator is change upper. Whatever the argument you will pass, the string you will pass, it will convert and change into the upper, and it will call the original function. Another decorator I have created that it will split your string into the parts and it will return the list. Okay. So, for example, if I want to apply this on this, here is my function. Let me copy and paste first. So here is my display function that takes a string that print the string. But before printing the string, I am calling one decorator that is change to upper. So here I'm calling the display function that accept hello dear, and let's see that what is the output. As you can see that it prints all the input into the capital letter. Why? Because I am applying one decorator that is change upper. Let's look at here the change upper definition. Similar to the previous one, original function wrapper that accept one argument and it convert into uppercase and it calls your original function. Now I want that when it will convert into the upper, it should split into parts. So I want to apply this also onto the display. So I can write here @ and split the string. So now you can see that here we are getting the output as hello and dear, that splits your string. So by using this kind of a statement, you can apply more than one decorator on a single function. But make sure that whenever you are using this statement, you are writing your decorator in a proper order. Why? Because when I have converted into upper, then I am splitting it. Split After splitting, you cannot apply this on the argument to convert into the upper. Why? What is mean by this? Just look at here. I'm changing the order of calling, so it will raise error. Okay, just look at here. List object has no attribute upper. Why? Because it will split the string, but we are converting the string into uppercase, but it will convert into the list. So list doesn't have any upper method. So make sure that you are using the decorators in a right order, in a proper order, and when you will write the code, then you will definitely use in the proper order. Now come to the practical example, that what is the actual use. This is the way that we create the decorators. So now the situation is, for example, you have two functions. I'm just copy and paste here to save our time. And here, if I write, so one function is a square that takes a number and it calculate the square of those numbers, and after that it will return the result. Similarly, I have written one more function, that is cube. It takes a number and it calculates the cube and it returns the result. Okay, so let's call this function by using some argument. So here the range is for example 1 to 10. I'm taking only 10. So this x can be passed here and this x can be passed here. So it will calculate the square and cube. Let me print first, then it will show the result. So let me print, and here if I print this one, because it returns the result, so we can print this one. So as you can see, we are getting the square, we are getting the cubes. The requirement is, I want to find out that what is the time of execution of this whole statement. I want to calculate the execution time of my function. So what I can do here is, I can write a code in which I will first, let me copy and paste first. I will write here a start time, and then when my function will be finished, then I will write the end time here. Okay, and after that I will print that how much time it takes to calculate the result. And to calculate the execution, we use the time module. Okay, so first understand the code. Just look at here, execution time taken in millisecond. So when you will call this function, it will first take the starting time. After that, it will calculate the result, and after that, it will calculate the end time. And we can get the execution time by subtracting end time minus start time. So we will get that how much time it is taking to execute the square. Just look at here the output. So execution time taken is 0.0 millisecond. We are getting the output. Okay, we can increase the values, then we can get the output that it takes some time. Just wait. Okay, I have taken a very large number. Let me do some short input. Okay, execution time. Let me increase this. Yes, as you can see, it takes 1.99 something. Okay. So this is the time taken by the square method. Now the requirement is, I want to find out the execution time of cube method, as well as I have created any number of the methods I have created. I want to calculate every method's execution time. So what will I do? I will write the same code in every method. Okay, I will write this statement, then I will copy and paste here. And time taken, execution time taken by cube, and here I will write by square. Now execute this. So as you can see, execution time taken by square is 1.98 something millisecond, and execution time taken by the cube 1.999 millisecond. So as you can see here, we are repeating our code here. Okay. And actually we are adding some functionality. Actually the functionality of the square function is to square, to calculate and to find the squares of all the numbers that I will pass. This is not the functionality of the square. And the functionality of the cube is to calculate the cubes of all the number that we pass. This is not the functionality. It is the extra functionality that we are performing through the cube function. Okay, so and you can see here that we are repeating the statement more than one time. Suppose you have 10 function and you want that you want to calculate the execution time of every function. So what will you do? You will write these number of the statement in every function. So the better way is to use the decorator. So how the decorator helps this one? So let me copy and paste. Okay. And now I will delete this and paste. Just look at here. I'm creating a decorator with the name of time calculation, and I will pass the function for which I want to calculate the execution time. So that function could be your square, that function could be your cube, and that function could be your any function name. And this wrapper will take args and coargs. I have already explained that what is args and kwargs. Now after that I will start the start time. This is the extra functionality that I am adding to my this function, and a result is equal, since this function will return the result, so I will call this function and store the result into result. And after that I will call the end time. So when this function will execute and finish, this will be your end time, and after that we can get the result, that how much time it takes to execute all the statements. Now this is my decorator. Now this decorator is applying into time call. So when I will call the square, it will pass a square here and it will calculate the whole statement and it will print the result. Similarly, I am applying the time call here. So it will pass the Q function into this and it will calculate the Q function. After that, it will find out the end time, and then you will get the end time of this functionality. As you can see, I'm not writing any kind of a statement in my square and cube to calculate the execution time, but I'm adding the extra functionality to the square and cube by using the decorators. Just look at here. So I'm calling. So square execution time taken is 1753 millisecond and cube execution time taken is 2678 millisecond. So as you can see here, I'm not writing the functionality, but still we are performing the same operation by writing only one time of the decorator, and we can apply on any number of the functions. So actually this is the use of the decorator. Decorator is actually used to calculate the timing, to maintain the logs. So for that purpose we use the decorator. So I hope this statement and this functionality is clear. Still just go and write the codes by yourself, then you will be more clear about the decorator. So I hope the decorator is now clear. Still, if you have doubt, then you can put your queries into the comment box. I'll definitely give you the answers. So thank you for watching this video. Please like, comment and share your views, and don't forget to subscribe my channel. Thank you. Bye bye.